There is a rock that cleans poisoned water. No electricity, no chemicals, no machines. Gravity pulls the water down. The mineral does the rest. And here is what they do not want you to understand. This technology is not new. It is not experimental. It is not waiting for approval from a government agency or a corporate research division. It is 2,000 years old. While modern engineers are selling you billion-dollar filtration infrastructure, ancient civilizations were already solving this problem with a volcanic crystal and a layer of sand. The Maya built drinking reservoirs that served tens of thousands of people for over 1,000 years. Persian engineers delivered clean water across open desert without a single pump. 2 civilizations, 2 continents, the same physics. And then, during the Cold War, and again during the conflicts surrounding Iran, governments quietly poured resources into researching this exact technology for military use. When the wars ended, the research disappeared, not destroyed, not disproven, disappeared. A filter that costs almost nothing is a filter that cannot be sold, and the global water industry is worth more than $300 billion a year. Tonight, we open the archive. Let us begin with an uncomfortable fact. The ancient world solved the clean water problem so completely, so efficiently, that the solution has survived in archaeological record for over 2 millennia. And yet your municipal water bill arrives every month without fail. The earliest large-scale example of mineral water purification we can confirm appears in the ruins of Tikal, the great Maya city of the Guatemalan lowlands, constructed around 500 BCE. Tikal had no river. Let that register for a moment. A city that at its peak housed between 60,000 and 100,000 people was built in a location with no permanent surface water source. No lake, no river running through it. Nothing that modern urban planners would consider remotely viable. And yet the city survived for over 1,000 years. The answer was engineering. The Maya constructed an elaborate network of reservoirs carved into the limestone bedrock, designed to capture rainwater during the wet season and hold it for use during the dry months. But captured rainwater is not safe water. Rainwater collects sediment, organic material, and microbial contamination as it flows across surfaces. In a dense urban environment, that contamination compounds rapidly, so the Maya engineered a solution. At the intake of the Corriental Reservoir, the primary drinking water source for the city, they installed a filtration barrier. Layers of quartz sand packed over deposits of a crystalline volcanic mineral called zeolite. This was not accidental geology. The zeolite used at Corriental was not local. It was transported from deposits nearly 30 kilometers away. Someone made a deliberate decision to move heavy mineral material across significant distance, specifically because of what that mineral could do. Zeolite has a microscopic lattice structure, a molecular cage, that chemically traps heavy metals, ammonia, organic toxins, and certain bacteria as water passes through it. The process is called ion exchange. The mineral carries a negative charge. Contaminants carry a positive charge. They bind. The water passes through clean. The Maya did not have the vocabulary of modern chemistry, but they understood the result. Now cross the Atlantic, move northeast across 2 continents, enter the ancient Persian Empire. Here, engineers faced a different version of the same problem. Not a city without a river, but a civilization spread across some of the most arid terrain on Earth. Deserts where surface water was unreliable, contaminated, or absent entirely. Their solution was the Qanat, an underground aqueduct system, hand-dug through rock and soil, designed to intercept groundwater deep below the surface and carry it horizontally across distance to populated areas. The engineering principle was elegant and precise. Because the tunnels ran underground, evaporation was eliminated. Because the water traveled through strata of natural rock and gravel, it was filtered continuously along its entire journey. By the time it reached the surface at a city like Yazd, the water had passed through thousands of meters of natural mineral filtration. Yazd still exists today. It still uses Qanat water. 2 civilizations, separated by the Atlantic Ocean, operating in entirely different geographic environments. Both arrived at the same conclusion. Mineral filtration, driven by gravity, is the most reliable water purification system available to human beings. No moving parts, no chemical inputs, no centralized infrastructure that can be shut down, sold, or taxed. That is not a coincidence. That is physics. For centuries, this knowledge existed in the walls of ruins and the sediment of excavated reservoirs. It was not forgotten because it failed. It was forgotten because nobody was funding archaeology as a public health strategy. Then, in 2020, a team led by anthropologist Kenneth Tankersley at the University of Cincinnati began analyzing sediment cores pulled from the ancient reservoirs at Tikal. They were not looking for a filtration system. They were studying the long-term history of water availability at the site. What they found stopped them. Using X-ray diffraction mineral analysis, Tankersley's team identified concentrated deposits of zeolite and coarse quartz sand at the intake points of the Corriental Reservoir. The distribution was not random. It was not natural accumulation. It was placed there. The team published their findings. The conclusion was precise. The ancient Maya had constructed a functional water treatment system using locally available and deliberately transported minerals, operating entirely on gravitational flow, capable of removing the categories of contamination that make water dangerous to drink. Modern laboratory testing on zeolite filtration confirms what the Maya demonstrated empirically. Zeolite removes up to 90% of heavy metal contamination from water samples. It reduces ammonia concentrations significantly. It intercepts bacteria and certain organic toxins through the ion exchange mechanism. It does this passively, continuously, without replacement intervals measured in months. A properly maintained zeolite filter bed can operate for years before requiring regeneration, and regeneration requires nothing more than a salt solution flush. The cost of a zeolite filtration system at the household scale is measured in tens of dollars, not hundreds. At the community scale, it is measured in hundreds, not millions. And yet when you look at the global water treatment infrastructure being sold to developing nations and rural communities across the world right now, you will not find zeolite filtration at the center of the proposal. You will find chemical dosing systems. You will find reverse osmosis membranes requiring electrical input and regular replacement cartridges. You will find centralized treatment plants requiring trained operators, chemical supply chains, and significant ongoing capital expenditure. Tankersley's research was published. It was covered briefly by science journalists, and then the conversation moved on. Why? Because the research confirmed something that the water treatment industry had known for decades and had built its business model around avoiding. The solution to clean water does not require the solution they are selling. There is a second layer to this story that requires specific attention. During the Cold War, military research programs in the United States and the Soviet Union invested heavily in portable and field-deployable water purification technologies. Soldiers operating in contaminated environments in the Middle East, including during the Iran-Iraq War of the 1980s, needed water purification that required no supply chain. Zeolite-based filtration was studied extensively in this context. The research produced results. And then the conflicts wound down, the classified programs closed, and the findings moved into proprietary military and industrial applications. Not public health applications, not rural development programs, proprietary systems, controlled by the organizations that funded the research. A technology developed using public military funding derived from 2,000-year-old Maya and Persian engineering was locked inside a procurement system inaccessible to the communities that needed it most. Let us be precise about what suppression means in this context. There was no single moment, no meeting room where executives decided to bury zeolite filtration, no government memo classifying the Maya reservoir system. What happened was more methodical than that, and in many ways more damaging. After World War II, the industrialized world needed to rebuild infrastructure at enormous speed. Governments needed solutions they could deploy at scale across entire cities and regions. The answer was centralization. Build one large treatment plant, run pipes to every home, dose the water with chlorine to kill biological contamination, add aluminum sulfate to coagulate sediment, pump it through mechanical filters. This system worked. But it also required construction contracts, chemical supply agreements, pump maintenance programs, ongoing municipal service relationships with private utilities. It created a permanent, recurring revenue structure, and once that structure was in place, it became self-reinforcing. Building codes were written around centralized water systems. Municipal planning frameworks assumed centralized water delivery. Engineering education focused on chemical and mechanical treatment. The institutional knowledge of decentralized mineral filtration did not survive this transition. It was not banned in a dramatic, legislative sense. It was designed out of existence. And here is the mechanism that kept it out. When researchers or engineers did propose low-cost mineral filtration alternatives, they encountered a specific barrier: the absence of standardized testing protocols for natural mineral systems within regulatory frameworks built entirely around chemical treatment. Chlorination has EPA standards. Reverse osmosis has certified performance metrics. Zeolite filtration, because it was never commercialized at scale within the regulatory pipeline, had no equivalent certification pathway. Without certification, it could not be approved for municipal use. Without municipal approval, utilities would not adopt it. Without utility adoption, there was no commercial market. Without a commercial market, there was no incentive to fund the certification research. The circle was closed. A filter that cannot be certified is a filter that cannot threaten the market. In a community that cannot access low-cost filtration is a community that remains dependent on the infrastructure being sold to them. This is not speculation. This is the documented experience of development organizations that attempted to introduce zeolite-based community filtration systems in parts of Africa and South Asia during the 1990s and 2000s. The technology performed, the water quality improved, the regulatory and procurement barriers remained. Now consider the military research dimension. The United States military, operating in arid and contaminated environments during the 1980s and 1990s, funded significant research into field-deployable mineral filtration. Some of that research emerged from analysis of traditional water systems in the regions where soldiers were deployed, including the Qanat infrastructure of Iran and Iraq. The research was not shared with public health agencies. It was absorbed into defense contractor programs. The knowledge that could have informed global water access policy was filed into procurement systems that serve military contracts, not rural populations. That is the suppression mechanism, not a conspiracy, a system that makes solutions profitable to some and inaccessible to many. Here is what the archive reveals. The Maya cleaned water for over 1,000 years with volcanic minerals and gravity. Persian engineers delivered clean water across open desert with hand-dug stone tunnels and natural rock layers. These systems worked, they were affordable, they required no ongoing chemical inputs and no centralized infrastructure. They were not replaced because something better came along. They were replaced because something more profitable came along, and the profitable system required you to remain dependent on it. A filter that any community can build from local minerals is a filter that cannot be sold on a recurring contract. That equation has not changed. The knowledge has not disappeared. It has been sitting in the sediment of an ancient reservoir in Guatemala for 2,000 years, waiting. If you want to uncover more forgotten technologies erased from public awareness, subscribe and hit the bell. The Lost Build archives are only beginning.